So now we're moving towards the next topic, which is unit step function of a Laplace transform. Before starting this unit step function, I just recall we have been discussed many topics which is in the form which is in Laplace transform. In previous lecture, we just defined the what is the initial and final value theorem. Both are the same, but we just keep in your mind the limit, the difference between initial and final value theorem is just a difference between limit. Okay, so now we moving towards the unit step function. What is the unit step function and how we get the Laplace transform of this unit step function? First, we know that what is the unit step function. Okay, so the definition of unit step function: if we have a function, and we denoted this function by ut. We denoted this function by ut or h of t. We have a function and the function denoted by ut or ht such that the value of this function ut, and this is called the unit step function, is equals to what? 0 and 1. When we get the value of 0, if t less than equals to 0, and we get the value of ut is equals to 1 if t is greater than equals to 0. Okay, so this is the unit step function. First we have to know what is the unit step function, then we will discuss what is the Laplace transform of this unit step function, or how we will get the unit step function of how we get the Laplace transform of unit step function. So here first we have to find, or we have to know what is the unit step function. So we have a function which is in the form of, or which is denoted by ut or ft, such that this ut is equals to, or this ut, it means the function of u, the value of this ut is equals to 0 when if the value of t is strictly less than 0, and the value of ut is equals to 1 if and only if t is greater than and equals to 0. Then we get, if any function which is in the form of like this 0 and 1, so this is called the unit step function. Okay, so this is a simple definition, or this is a small definition of unit step function. So now we have to find the Laplace transform of unit step function. Okay, so now we have to find the Laplace transform of unit step function. How we get the Laplace transform of any unit step function which is like ut, or which is denoted by ut or h of t, whatever you write. So here, as we know that Laplace transform any function f of t is equals to what? This is 0 to infinite e raised to power minus st f of t into dt. This is a general definition of a Laplace transform. So now we have to find the Laplace transform of this unit step function. So here we can write Laplace transform of u of t is equals to, this is same 0 to infinite and e raised to power minus s of t. This value is ut and dt. Okay, this is the Laplace transform of ut. So here we can easily see that the value of t, because the function is in the form of t, and the integration with respect to dt, so limit should be in the form of t, and the t is 0 to infinite. It means value of t is must be 0 and greater than 0. It means the value of t is greater than 0 or equals to 0. So the value of t is like this, and we know that the definition of unit step function, here we can write, if the value of t is greater than and equals to 0, then find the function of ut. It means the find the value of unit step function ut is 1 if the value of t is greater than or equals to 0. Here you can write, here you can see the value of t is greater than or equals to 0, so the value of ut, then the value of ut is equals to 1 from the definition, okay. Ut is equals to 1. So here we can write 0 to infinite e raised to power minus s of t. The value of ut is equals to 1, and this is d of t, and we will find the u of t, unit step function of Laplace transform of unit step function. So this is so simple to get the Laplace transform of any unit step function. So integration of this e raised to power minus st, again e raised to power minus of st, and the function is st, again t is 1, so we get minus s in the denominator, so 0 to infinite. Now put the limit. First we put the limit of upper limit, so which is infinite. So here e raised to power minus s of infinite upon minus s. Then now put the lower limit, which is 0. So this is e raised to power minus s into 0 upon minus of s. So here this get this e raised to power infinite, s into infinite, again infinite, and we get e raised to power infinite, and the value of e raised to power infinite is 0, 0 upon infinite, 0 upon something is again 0. So now here minus e raised to power 0 is 1 upon minus s, and this is cancel out minus minus. So here we find the unit step function, Laplace transform of unit step function. It means Laplace transform of u of t is nothing but 1 upon s, and this is the our solution of Laplace transform of any unit step function, of the Laplace transform of unit step function. First we must be know what is the unit step function. It means the definition of unit step function. Here the definition of unit step function ut, which is 0 if t is less than 0. The unit step function value ut is 1 if t is greater than or equals to 0. So now Laplace transform. Now we have to find the Laplace transform of this ut. From finding this ut, we know the general definition of the Laplace transform. This is 0 to infinite e raised to power minus st f of t dt. So now we have to find the Laplace transform. L of ut is equals to 0 to infinite e raised to power minus st ut dt. Here the limit is 0 to t, 0 to infinite, 0 to infinite. The values, you can easily see the value of t varies 0 to infinite. It means the value of t is greater than and equals to 0. It must be 0 or greater than 0. That's why here we can write t tends to 0 to or maybe more than 0. So that's why if the value of t is greater than or equals to 0, then we put the function, we put the value of ut is equals to 1. So here we can we put the ut is equals to 1. Then this is the solution. Now at the last, the Laplace transform of any unit step function is 1 by s. Okay. So this is the unit step function. Now in the next video we will discuss some other unit step function. It means this is a unit step function. After this we will discuss the shifted unit step function, and the third one is impulse unit step function, which is related to this unit step function, and we find the Laplace transform of this shifted unit step function and the impulse unit step function. We will discuss in the next video in these two unit step function. Okay, from today is enough, and I hope you all understand what I am talking, what I am right here, and this is the proof of your unit step function. So we will meet in a next video lecture. Okay, thank you.